So greetings for the day to all of you. Today I, Dr. Amarpreet Singh, in front of you with yet another lecture of the subject Artificial Intelligence. So today in this presentation and in this lecture, I am going to cover the two topics. One is constraint satisfaction problem. First topic is constraint satisfaction problem, which is also in short known as CSP. And the second one is mean and analysis, which in short is known as MEA. So these two also come under the heuristic techniques. First problem or first technique is known as constraint satisfaction problem. In short, it is known as CSP. And second is mean and analysis. And in short, it is known as MEA. First, I start with the constraint satisfaction problem. So what says constraint satisfaction problem? What is the meaning of the word constraint? First understand. The meaning of the word constraint. Constraint means limitation. Any limitation is imposed or imposition. Some conditions are imposed, some limitations are imposed. There, if we have certain problem and you are asked to solve this problem, so you may right away start solving the problem. But there are certain problems. If it comes under the constraint satisfaction problem, then before starting the solution, finding the solution of the problem, you must look onto certain constraints are imposed. That these are the constraints that you have to follow while solving the problem. So you have to see that when you start solving the problem, you follow the constraints that are laid down. You will solve the problem in some restricted manner because constraints impose some restriction that you cannot do this thing or you can only do this thing. So this is what constraint tells. So you are given a problem, you have to solve the problem, but along with the problem, you are also given the list of constraints. So while you are finding the solution for each and every step, you have to see what are the constraints now. And these constraints are not static. The list of constraints is not static. The list of constraints is dynamic in nature. Means at first point when you start in that list, it may have n number of constraints. You did first step following the constraints, it may happen some more constraints add on when you follow some steps. So therefore, the list of constraints is dynamic in nature. So you have to follow the list of the constraints on each and every step. When you want to take one step, then you have to refer the list of constraints. So that restriction is always there. So this is the overview or the outlook of the constraint satisfaction problem. Suppose I give you the two locations. The first location is the start point and second location is the goal point or the stop point. So this is the start and this is the goal point or the ending point. So in between different, you can say paths are available. You can move through this path or you can move through this path. So hops are available. You can take any hop at a time. So from start, you can follow this path or you can follow this path in general or you can follow this path or you go this way, then you come to this way, then you start this or again you go there, then you come here and zigzag manner or from here you come here, then you can come here or you can go this. So any path you can follow. It is up to you. So you, if the condition can be shortest path or something. But if I put some constraint that while moving, you can only take the right turns. You can only take the right turns. You are not allowed to take the left turn. Then what will be from here? You want to move here, so it is a right turn. So you move here, it is a right turn. You move here, so you can take the straight or the right turn. You cannot take the left turn. You came here, from here, if you want to move here, then it is a right turn. So this path cannot, you cannot follow this path. Then let's try here. So you want to follow this. So first turn is also the left one, so you cannot follow this path. So in this way, you can follow only this path where you do not have to move any left turn. So if you follow this path, then go you have taken right, straight, but now to go you take the left turn, which is not allowed. If you want to go to this part, the first moving also is the left turn, so you will not go in this path. So this path is the only way left going. So you have to follow the constraint. So if it says the first step, the restriction is you cannot move to the left turn only for the first step. Later on, you can move to the left. So if this type of constraint is there, then you can follow this order because first step you follow right, then you move straight, then you follow left. Then this part can also be your way. So this is what is the constraint satisfaction problem. While solving the problem, while taking the step, the list of constraint is there, and that constraint list is dynamic in nature because it may happen when you take the first step, some more conditions are evaluated which also come into the action as a constraint. For taking the next step, you have to follow that constraint also. So this is basics of the constraint satisfaction problem. So under constraint satisfaction problem, one important problem category of problem is the crypt arithmetic problem. So I will do the crypt arithmetic problem, one of the crypt arithmetic problem for you. That crypt arithmetic problem, crypt arithmetic problem. So crypt arithmetic problem is a type of problem in which you are given some alphabets and your constraint is you have to assign one digit to one particular character of the alphabet. And once one digit from 0 to 9, if it is assigned to one character, or one alphabet, it cannot be assigned to another alphabet or character, and the vice versa. So this is the condition for a crypt arithmetic problem. So this is the condition for crypt arithmetic problem. So one simple example for crypt arithmetic problem is like you have to evaluate the solution. Like there is 10. It is very common example given by most of the authors. Therefore, I am giving this example only. Just more, and you have to evaluate as money. So we want to see what is the solution of sand plus more is equal to money. So what digits you will assign to S, E, N, and D, then N, O, R, E is going to be assigned, then Y. So these are the different alphabets where you have to assign the different digits so that it is evaluated. And the according to constraint satisfaction problem, the constraint is once a digit is assigned to any character of the alphabet, same digit cannot be assigned to any other character, and the vice versa. Vice versa means if one character holds one digit, so that character or that digit cannot be given to any other character. Simple way of doing is the way I will just solve for you. You just notice to write all these alphabets one by one. So it is S, E, N, D, M, O, R. So you write first of all 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then say 0, 1, 2, 3, 4, 7, 8. And you write all the alphabet here. S is there, E is there, N is there, then D is there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then M, O, R, E is already covered. E is already covered. Then M is also covered. O is also covered. N is also covered. E is also covered. Y. So only this constraint is given. Now you start here. Now if you say you can assign any digit to S, M, O, and O. So these are the four digits. 1, 2, 3, 4, 1, 2, 3, 4. The output contains the 5 digits. So obviously, if some digits are added and you are getting 4-digit number, adding to 4-digit number, the result is 5-digit number. Obviously, carry is there. Obviously, carry is there. So the maximum you can attach to S is 9, and maximum you can attach to M is also 9. But if 9 is attached to S, then no 9 can be attached to M. So here M can be given any value from 8, 7, 6, and odd. Here, but whatever the thing you may give, you may give 8, 9 and 8, output will be 17. If you give 7, output will be 16. If you give 6, output will be 15. What I want to say, carry the result only in 1. Because maximum both digits can be 9, but it is not a here because it is a constraint satisfaction in the arithmetic problem. Both digits cannot have 9. Or it may happen that a upper value is also M, lower value is also M, then 9 can be given. But after adding 9 and 9, the result will be 18. Means carry will always be 1. So here the carry will always be 1. So 1 is assigned to M. M, what is the sign? 1. So obviously if this M is 1, then this M will also be 1. Same, because same digit can be, if M is given 1, all the M will be given 1. Clear? Then come to S. We have the carry here. Carry. So if it is 1, to generate the carry, this S can be 9. Can be 9. Then only 9 plus 1, it will be 10. Then carry will be generated. Or one thing more can happen. It can be 8 and addition of E and this O coming to this may generate the carry which come here. Then it can be 1 plus 8 plus 1. Then it can be 10. But if 1 is given here, so if it is coming there, so we have to try with the 9. So let us try with the 9. Because 1 is already assigned. So carry can be come from here, that is 1. Then 1 plus 8 plus 1, then it can also be 10. Then it can also be 10. But let us try with the 9. So 9 plus 1 is 10. Means this 4 will be 0. This 4 will be 0. So then only this here 1 comes. So S is 9, M is 1, O is 0, M is 1. This has been set. Now come to, if this O is 0, obviously this O will also be the 0. Because this O is 0, this O will also be 0. So now we have to find the value of E. So if we put E as 1 cannot be given, let us try for one thing more. Once you given M1, what you will do? Here it is M. So 1 has been assigned to M. So what is the value of M? It is 1. Here value of M is 1. So M cannot be given any other digit. And also this 1 cannot be given to any other character. So you cut it side by side. You cut it side by side. Similarly, when 0 was given to O, for O it was 0. So O cannot be given any other digit. You cut all the digits. And this O cannot have any other digit, and this 0 cannot be given to any other character. You cut here. So M is given 1, O is given 0. Then S is given to 9. S 9 has been given. So S cannot get any other digit, and this 9 cannot be given to any other character. So you cut down this. So this is the way you have to solve this chapter. Now come to this E. So 0 has been given, 1 has been given, try with 2. If you give 2 here, 2 plus 0, 2. So E also gets 2, N also gets 2. Okay, so it cannot happen. It means some, and this also, this or E also becomes 2. So and 2 here, 2 here. So same cannot be given. Similarly, 3 here, 3 here, because 3 plus 0 is 3. 3 cannot be given. Suppose you say that if you give 3 here and some carry comes from this side, n plus r, here some digit and some carry comes here, then 1 will be there, 1 plus 3, then n will be 4. So if you like this, 4 here, this you will give 4 here and here 3. So 4 plus something cannot be 3. So this is not right. So you try for another. Then you try for 4. So 4 here, 4 plus 0 is 4. But you say some carry is there. Suppose 1 comes here, then it will be 5. Then E will be 4. Then N will be 5. So 5 plus R. R cannot be. So 5 plus something cannot be 4. So this is also not right. Then you try for 5. 5 plus 0, it is 5. But suppose some carry is there. You add N and R, some carry is there. So here it can be 6. It can be 6. So you give it 5 here. So then this will be 5. This will be 5. So you try, if this is 6, this is 6. So let us try now. If this is 6, this is 6. So it can be 6 plus something. It can result in 15 if some carries there. So let us try with 5. So it is hit and try. You have to try with another digit. So let us try with 5. So 5 is here, and you suppose that some carry comes because 5 is here, 0, 5, and cannot be 5 now. Means we have to generate some carry here. You suppose some carry is generated from these digits. So 1 plus 5, 6. So N is 6. So here N becomes 6. If you have given 5 here, same 5 will be here also. Same 5 will be here also. Now you try. So 6 plus something, you want 5. So 6 plus 9 can be 15, which will generate the carry. But 9 is already given here. So you cannot give 9. So what you can give? That gives us 8. So 6 plus 8 is 14, and you feel that some carry goes there. So 1 plus 6, 7, 7 plus 8, 15. Yes, it is okay. So this one comes here, it becomes 15. So E is 5, E is 5, E is 5, N is 6, N is 6. So it suits. So it is suiting. So you give this one. Now come to here, 5. So 5 is there. So what you give to D? You give 7. Because 6 is also given, 5 is also given. You can try with 4. 4 plus 5, it is 9. But you want carry here because you have already thought of the carry. So 4 cannot be given. If you give 5, 5 cannot be given because 5 is already given. Then 6, 6 cannot be given because 6 is given by taken by N. Then you try for 7. So 7, yes, 7 can be given. So 7 plus 5, it is 12. It is 12, and 2 is not taken by any other thing. 12, 2 here and 1 is there. So this suits you. So output is 9, 5, 6, 7, 1, 0, 8, 5 is equal to 1, 0, 6, 5, 2. So this is the solution of this flipped arithmetic problem. For this way, you have to solve. You can be given any problem. So this is what the flipped arithmetic problem. So the solution of cent plus money is 9 to S, 5 to E, N6, D7, M1, O0, RA, and E5. So this is the, you have to check it that how many E was there. One E, this, and this. All E should have same value. So E having 5 here, E having 5 here, E having 5 here. Two N's, N and N, both are having same value, that is 6. 2N, 1, 2O, both are 0. So you have to check also. So this is the way you solve the flipped arithmetic problem. So at your end, you can access any other thing. So after this, you can also be given, once you solve cent plus more money, then you can be given what is solve send plus more money, but you can be asked what is the value of S plus N S plus O plus N. What is the value of sun? SON. So you can also be asked what is the value of sun here, or what is the value of END, or what is the value of men? M plus E plus N. Once you get the each value of S, E, N, M, then you can solve. M is 1, E is 5, N is 6, D is 7. You can add and find the final value, that is 6 plus 6, 12, 12 plus 7, 19. So this way also you can be asked. So this is the way we solve the flipped arithmetic problem. So this is all about the constraint satisfaction problem, and under the constraint satisfaction problem we have done the flipped arithmetic problem. So the next topic for the day is means and analysis, or sometimes it is a means and analysis. So what is this type of technique? Just come to see. Suppose I will tell you some examples of means and analysis. You have given one start point, one position or the current state, and this is the course. So here also you have to, your column is you have to find the solution from where, from this start state you have to reach to the goal. Now, what is the method under which you try to solve? What is the technique applied is you find the difference between your start and these two states. You find the difference. What is the difference? That is, you do G minus S. This gives you the difference between these two states. Once you get the difference, then next step is you try to find one operator. You try to find one operator whose implementation will reduce this difference. So you have to find one operator. There can be list of operators. There can be list of operators or operations or the processing. So from that list, you have to select one operator that will reduce the difference. Now this selection is very important because there can be more than one operator which reduces this difference. So now you have to select the best one. Here the heuristics come. Which operator you will select. So whatever the operator you have selected, you try this operator to reduce this difference. You apply the operator. So it is the simple method. Then after applying this operator, this difference may get reduced. This difference may get reduced. So earlier the difference was this. Now after applying this operator, you covered some distance. So now this and this difference remain like this, very less. Now this is the new difference. Again, once you find the new difference, this is the new state S1. is again same because it becomes the current state now to move somewhere. So now this difference is G minus S1 you can say. Now you find again the operator which may reduce this difference. It can be the same operator which you have applied earlier, or it can be a different operator now after taking the first step. Again, whatever the operator you have selected, you again apply on this, which will reduce the difference. And now suppose again applying this. Now the new result is this difference remains this one. It becomes S2. So now the new difference will be G minus S2. Again you will apply the operator. Now again same operator can be built or another operator can be there. Then so this is the recursive process. This is the recursive process. So means and analysis is the recursive process. Here in each step you find the difference between your current state and the goal state. Then you find some operator which you apply on this, which may reduce this difference. After doing that, you find the new difference. Again, from the list of operators available, which can be applied in this state, you apply that. Again, new difference is there, and this work will continue until your difference becomes zero. Your difference becomes zero. So this is the way that means and analysis is taught. So this is the simplest. But one point you have to notice. So once you only we have seen that find difference, select the operator, apply the operator, find new difference, continue this process until the difference is zero. So I am going to add one more point step in between. What happens? One, suppose you have selected some operator. You know that this operator, if I apply this operator in this problem, the difference will be reduced. But sometimes what happens? You are not in a state of applying the operator. You are not in a state of applying the stator operator. Therefore, some sub problem is there. So once you select the operator, now it may be the condition that this operator may not be directly applied because it is not in the that state. So we have to also see after selection that this operator can be applied or not. If not, then it is a sub problem. Here we will come on to the state where this operator can be applied. Suppose there are two cities. Suppose this is Amritsar and this is Jalandhar. You start from Amritsar and you have to go to Jalandhar. So when you will find the solution, when the milestone reading will become zero. At present it is 80 kilometers. At present it is 80 kilometers. So you start, what are the operators for you? You can start your journey by public transport, bus or train, or your vehicle, car, or any two-wheeler. So these are the operators which will help you to reduce the distance or the difference. So these are the operators, list of operators. Clear? Now you opted for car. So you started your journey with the car. So you started your journey with the car. When you started moving towards this side, one stop comes, suppose Vyas. After taking a leap of 30-40 kilometers. So again, you evaluate yourself. Now this distance between Vyas and Jalandhar is 40 kilometers. So now what happens? You have to choose how to reduce this distance. Again, you choose the car. Again, you choose the car and you apply this. This is the simplest one. But what happens? Maybe after reaching to Vyas, after reaching Vyas, there is a restriction. Some jam is there. Some jam is there. So you cannot move now. You cannot move now. So what operator you will allow if there is jam? You cannot do anything. You have to wait. You have to wait. But you want to know that, and it is very urgent that you have to reach Jalandhar in time. So there is a railway station. There is a railway station, and jam is there, cannot move forward. So you facility of parking is there. So what you can do now, you can park your car at the Byas station and you now go to the you for the train. You have the train and rest of the journey you start with the train. So at this moment, now your operator has changed. You started with the car, some difference was reduced, but later on again taking first step, first halt was there, again you evaluated, and but now that in the list of operator, bus cannot go because jam is there, car cannot go. But yes, railway track was there and trains were going on. Then you may change the operator and move to the train. It may have happened, second condition, here also nothing jam was there. Again you applied the car, you again go through car, and now you come to just you can say outer of Jalandhar. Outer of Jalandhar, and this is main Jalandhar city, and distance is only 1 kilometer left. But here again there is a jam. Now you can see, you can apply the another operator. Means you can now walk through. You can park the car and you can walk through for 1 kilometer. So in this situation, the next operator is walking. In that situation, the next operator was train. But if nothing jam is there, so what is there, again you select the car. So this is the simplest way of solving the problem. One more condition. In the beginning, you chose car because you see that this is a private vehicle and you can move fast and reach. But when you selected the car, your car is punctured. So you know that from bus, train, cycle, scooter, bike, car is the best operator, which will reduce this difference very early. But then you went for car, but it was punctured. So this operator cannot be applied because it is not in that particular state. Now you have to, if you want to apply this operator, you have to make this operator into that state where it can be applied. So that is the sub problem now. Now first you have to repair the puncture and then move by car. So this is the sub problem now. You have to let it repair. So this is what the means ends analysis is. So I have also made the slide presentation for the means and analysis. I will share that with you. So means and analysis, just see the screen. It involves detection of difference between the current state and goal state. Once difference identified, an operator to reduce the difference must be found, but perhaps operator cannot be applied to the current state as we have selected this operator car, but it was punctured. So it may be that this operator cannot be applied to the current state. So sub problem of getting to state where operator can be applied. The sub problem is you get this puncture repaired. Then you solve the sub problem. Then you apply the operator. Operator may not result in goal state because when halt was there, jam was there, find jam near Bias. So operator did not put you to the goal state. So now second sub problem of getting from a new state to goal state means now you have to select the another operator like we selected the train. So this is the way the means and analysis is applied. Now I will give some technical problem also that I will show in a screen. So MEA process applied recursively. So MEA is a process, it is recursive in nature. At every step, you have to select one operator. You have to see that operator can be applied or not. If cannot be applied, then sub problem is there. You come into that state, again you apply, then you again find the difference. After finding difference, again you evaluate, again you find the operator, again you find the difference, and this will continue until the difference becomes the zero. Next, take one more example, that is the problem for household robot. So what is problem is, one robot is there. One desk is there. It is some item on a desk. Those two items are there. Item 1 and item 2, and this is your desk. So through robot, you have to move this desk from room 1 to room 2. So you have to move this robot from room 1 to room 2. So this is the problem. So now what happens? You can do two things. Two operators can be applied. One is push or another is carry. Push can, if the item or a desk is very heavy, then you have to apply the push. If it is not heavy, light weighted, then you can carry. So if both the things are there, desk is also there and item is also there. So desk can be pushed and item can be carried and then can be placed over. So it can be mixture. If all the things are very heavy, then you have to push only. If both the things are desk and your items are light weighted, you can carry all the things. If desk is heavy and item is light weighted, then you can pick the items, push the desk, then you can push the item. So what operators are available? So operators are available. First is push. Push is for to move the object. It can be desk or the item. You can either go for push or either go for a carry. For moving of robot, because robots have to push. So moving the robot, what is operator walk? The clearing of object. You want to clear the object from the desk. The operator is pick up. Get object on object. So if you took one object and you picked up, again you have to place on it. So that is get object on object means place operator has to be applied. Get arm empty. If robot has to push something or pick something, earlier its arm should be empty. To get the arm empty, it can be put down or place. And be holding the object means pick up operator. So these are the operators. The combination of these operations, application of these operators will help you to move the desk with the two items from one room to another. But there are three conditions. How this operator can be applied? Push can be applied, if this is the condition. So preconditions are good. Carry can be done if this is the precondition. You can pick something, only the precondition is if your hand is empty, if your arm is empty, this Robert arm is empty. So if Robert wants to apply the operator put down, means something should be in its hands, then only it can put down. These are the preconditions. Push, for push, the object should be heavy. If you want to carry, the object should be small and less heavy. But these are the preconditions. To apply any operator, we have some precondition. That was given to apply the operator. We have to see whether you are in a state to apply that operator or not. If you are not in a state to apply that operator, then it is a sub problem. You have to come to that particular state. So these are the operators. Push. So object and location has to be given what you have to push and where you have to push, where you have to take it from one place to another. So location has to be given. So then only push operator is applied. These are the two parameters of push operator. And the two condition in our case. So if Robert is there and object is there and object is large and heavy and you have to clear the object and your arm should be empty. So these are the three conditions to apply the push operator. And once you apply the push operator, if you are in that state, condition is cleared, what will the result? That is also given. For applying the carry also needs what you have to carry object and at which location. So there should be Robert and object and carry will only be applied. The precondition is if it is a small object. So walking does not have any precondition. Robot can move anything. Pick up, it can be only done if Robot is there and object is there. Then the object can be picked up and the arm should be empty. These are the preconditions and the results. This is all about the means and analysis. Today we have covered the two topics. First topic was PSP, that is constraint satisfaction problem. Under this, we did script arithmetic problem. And second topic was MEA, that is means and analysis. Yes, given one live example of moving from one city to another city, and another example was the robot moving, pushing, or carrying. Yes, with two objects from one room to another room, room 1 to room 2. So, algorithms was also discussed for constraint satisfaction problem also, or family also. So, for algorithm of constraint satisfaction problem, you have to see the problem, you have to look for a list of constraints, then you apply some operator, again you see the list of constraints, so it is a dynamic in nature. So once you go through all the things, so this systematic problem of constraint satisfaction problem can be solved. And means and analysis, it is also a recursive. Means and analysis is the recursive process where again at every step you have to select the operator and check the state whether it can be applied. If it cannot be applied, then it is a sub problem. You solve the sub problem, then apply the operator. Before applying the operator, you find the difference, apply the operator. After applying, again find the difference, and this process will continue till the difference is zero. This is all about the constraint satisfaction problem and the means and analysis.